Okay, I searched for sorted. Let's see what the sorted function does. The sorted function returns a new sorted list. So we give it a key and it returns a new sorted list. Let's see how this is working. They don't have examples, but yeah. For example, I can look up in the documentation. They have key. What's the key? Come to key. What's the key here? Static method. It's not some, we need sorted. Key specifies a function of argument that's used the exact comparison. K from each element is iterable. The default value is not. Okay, we need to do the same as before. Compare fn. Let's call this compare fn. This as you see means how we want to sort our elements. But it will be the same as before. To this sorted function, let's print it. For this sorted function, we can also reverse sort this. For example, I can give it another parameters called reverse. If I give it true, it will sort, but in reverse order. For example, now Rasul is the first, even though letter R comes at the last. Now Kenan is the last because we sorted in reverse. Okay. Okay, so this is how it works. You can always use the sort functions. Yeah, and maybe let's have just break and then let's continue because this is a little bit heavy. I will write this one just for fun. Maybe you can also write without waiting for me. Although this might look complicated, this is some formula which is, I don't know, several hundred years old. I'm not sure. This is a formula to approximate number pi. So you know the pi is 3.14 and stuff. This is very old formula, and as you know, this is just for loop in. This is for loop in math. This means loop should start from 1, and it shouldn't end. It should end in infinity, but in our program we cannot end at infinity because our resources are limited. I want my computer to do something else. It shouldn't be endless. We can go, for example, not till infinity, but till 1,000 maybe, till million. This formula just means sum these numbers until infinity. And what we sum just -1 over k plus 1 and then divided by 2k minus 1, where k is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. K is just numbers from 1 to infinity. And how we use k here, -1 to the power of k plus 1 and divided by 2k minus 1. I will write this for you just to show that it's simple. For example, let's call this approximating number p. I can create a result here. Result is just 0 because I will sum these numbers. What is this sigma sign? This is just for loop. It means we start from 1, we go to infinity. We won't go to infinity, we can go to the million maybe. Let's start from k, which will start from 1 and will go to infinity. Instead of infinity, let's write, I don't know, 1 million. Okay. And what I do here, -1 to the power of k plus 1. Okay, let's call it in English, what we call this مخرج, surat, denominator, and مستكنة değil. Yes. Denominator and numerator. Numerator. Okay, the top one is numerator. Okay, the numerator is -1 to the power of k plus 1. Numerator is -1 to the power of k plus 1. And denominator is what? 2k minus 1. 2k minus 1. Okay, and we need to divide them. Let's call this ratio equals the numerator divided by denominator. Okay, so this is the ratio. And this sigma sign means that we need to sum them. What we sum, we add it to the result. Result plus equals to ratio. And whenever we finish summing all these elements, we will multiply them by 4. Like if I print the number pi will be 4 multiplied by result, whatever the result is. If I print number pi, what will I get? I will get something close to 3.14. So this is 3.14 and then 15. Then the later numbers are not accurate because this formula is actually very, very old, like hundreds of years old. And this is very like dummy way to approximating the value of p. I don't know, they use it for some scientific reasons. And nowadays people approximate like million digits of pi. You can see some website like this. I don't know what's the like reason of this, why people does this, but like this is some digits.
They use what I think they use maximum 100
for what?
100 numbers after
Comma. Okay, I'm not sure why they use it. Maybe, for example, because a number pi actually never repeats itself, that there is nothing repeated here. They are all just random numbers. Maybe some computer scientists use them to get some random numbers, but I'm not sure.
Really? That's how they calculate randomity.
Actually, it's hard to find something random. Okay, it's because there isn't anything truly random. In computer science, for example, let's in Python there is a module called random. Okay, I can print some number here. Print random random int. I think it's called rand int. Okay, I say to give me some random number between 1 and 6. Let's print it. It will give me 2. Next time it will give me 4. Next time it will give me 2. And they don't call it a random number. They call it pseudo-random. Okay, because this is not truly random, and this is not safe to rely on them that they are really random. And they call it pseudo-random. It's not safe to use them some, I don't know, cryptographic functions like this. Like randomity is really hard. Maybe you can look on YouTube and search for is anything truly random? Why are we here? Why are we living?
How computer calculates?
A computer might, I don't know, get current time, I don't know, can do something with it, and then get some random number from it. But some security stuff is really heavily related on random numbers. For example, let's say we are exchanging a message and I want to, I don't know, encrypt this message somehow. And I want only this person to be able to read it. And we need some random number for it. If anyone can guess that random number, it means we are not safe. Only I should be able to guess that random number. And for example, this randint function will give you random number, but it's not safe to rely on them. Maybe some hackers can do something with your computer and can guess what will be next random number. Okay. There are some cryptographic random functions. They are really safe, like they rely on heavily like on mathematics, and I don't know how exactly they get it. I don't know, there is some majors in cryptography. They study years of like years of cryptography. But for example, this number is not safe. If I want to build a game, I don't know, I want to build some game based on randomity, it's okay. But if I want to use them for some security stuff, for cryptography, it's not safe because they're called pseudo-random, not random. Maybe they use digits of pi for this reason, but I'm not sure. But I know that people are really like dedicate their lives to number pi for some reason.
I also see that they can use it by graphics in the crypto industry. For example, Bitcoin, like that. Because cryptocurrencies has such complicated graphics. So I think they must be way too much accurate in order to.
Yes, actually, there are some functions called hash functions. We can talk about them. Okay, so this number is just some approximation of pi. It's not pi. There are some really advanced mathematical models to get like million digits of pi. This is not approximate. Like this is not accurate. I can add another 2 zeros here and let's check if this works. But it will take my computer a little bit time. You know, it's still calculating. The for loop is still running. I'm not sure if it will stop soon. Let's just wait. Okay. And we are doing it just for 1 and 2 digits of pi. I don't think that it's worth it. Okay. Okay, I want you to, what to do? I want you to write some code and just to find arithmetic mean of a list. Okay. I want you to write a function which is called arithmetic mean. It will get an array as input and it should return something. Okay. Whenever I give this list, you know arithmetic mean, like you sum all the numbers and you divide by length of this list. For example, when I give it this list, it should give me 5.2. If I give it this list, it should give me 3. And just try writing this function. I even wrote the function template for you. You can try writing this function for yourself. So you have two operations, right? You need to sum all numbers, and then you need to divide the sum by length of the array. What? Yes, always use tabs. Just actually, like your editor helps you a lot. For example, like I press enter, you see. Let me just. If I press enter here, you see it always indents my code. M1. Do you use sum function?
No, that variable equals to sum.
So to use like this.
Yes.
Yeah, sure, it's also acceptable. It actually does what we did with sum, like this for loop. Python has built-in function called sum. It just takes a list and sums the numbers. Let me know if you need any help. If you complete it, just test it with empty list. Can you guess what will be the result if you give it empty list? We have a list, but we don't have numbers inside the list. What did you write? You can just copy it.
No.
Yes. Can you read the error? Last line of the error.
There's mistake in it.
Yeah. Can you read the message of the error? It says something. Yes, it means that we are dividing by 0. What's 0? It's size of numbers. Okay, can you prevent that we don't get the error? Yes, to prevent that case, I can write an if statement like this. If size of numbers is 0, I can just return 0 without the bit divide. Okay, Murat, did you write? You can just copy it, but make sure that you understand. After size of numbers or after here, I don't know. Just before you do the division, just check if the size of numbers is zero. Aha. İki beraber mukayese, iki beraber comparison operator. İşte iki beraber koyuruq ki, çünkü müqayisə edirsən ki, görəsən bunlar bir-birinə bərabər diyorsun. Bir beraber assignment'tir. İşte assignment, yəni ki, sıfırı bu variable'a assign edir. Aha. Belə. And just to get, for example, whenever I call an empty list, what happens? The size of numbers is 0, and I get this error. If you read this error, it says that whenever we divide this, it gives me error which is called zero division error, because I divide by 0. Like we cannot divide by 0, because like list is empty and size of list is 0, and I divide here by 0. Like size of number is 0 because list is empty. And we get division by 0 error. We can prevent it by like this. For example, if size of numbers is 0, then we just return 0. It's okay. And what did we tell about return? Whenever you write a return statement, function stops at that point, just like break. Like if I write return here, then this part won't work. For example, if size of number is 0, we will return 0 and the rest of the code will not work. If now size of numbers is not 0, then the rest of the code will work, but this statement will be skipped. Okay, let's write another function which is called what? Section. Reverse Caesar cipher.
Reverse was the thing that we And we by our names and names.
Reverse. That reverse actually means that like you don't need to sort it, but you just need to reverse it. For example, this might be like this. This is not sorted, but I can reverse it. Generate password. This is some interesting application, generate password. It is asks us to write a function which is called the generate password. It will get length of the password by as a parameter. For example, if I give it 32, it should give me 32, like a password is 32 letters. We can actually try this.
The random.
Yes, we need random numbers to get some password. Okay. Let's say I have this, I don't know, I have this alphabet. Okay, I have these letters. I also have these letters. I also have numbers, okay? And I want to get a random letter from this string. How can I do this? I need a random index, okay? Random index should be a random integer. Random integer between 0 and the length of this, whatever is the length of this alphabet, okay? So between 0 and length of the alphabet. If I print random index, it will give me different, like between 0 and what's the length of this alphabet, like 26 plus 10. 4, 1, 49, 2, 24, 23, 9, 23, 46, 53. It just gives me random numbers between 0 and the length of this alphabet. So it means if I can get the random number, I can also get random letter. If I use the string like this with bracket signature, I can get random letters. I just get random letters and digits from our alphabet. You see sometimes they can be same, O and O. String index out of range. Yeah, we need to, I think, exclude this letter. Let's call it alphabet size. So what if you see what I do here? I just, for example, if I want to get password with 4 letters, I do this 4 times. This is my password. Let's go like random password generator and see if they have some passwords. Let's say use password generator. For example, I choose my length of my password and it gives me just some random numbers. I can say that exclude symbols, just use uppercase letters, lowercase letters, and numbers, and it gives me just this. So let's say I have just 4 letters. It does the same thing with me. Okay, does the same thing with me. I just did this 4 times. Okay, and let's create a variable called password length, which is just 4, let's say. I need to do this 4 times. For I in range from 0 to password length, I will do this. Model object is not callable, not random. It should be range. Why did I write random? KKK, LLL, LLL. Yeah, you see why we have the same letters, because we need to generate random int each time. I need to generate this random index each time in the loop, not just one time, just each time. So I have this 4 letters next time, this 4 letters next time, this 4 letters this time, next. I just pick some letters from this alphabet. And to just password equals to just empty string, and I add this random letter to my password, and at last I print the password. What happened? Plus equals. This is my password, this is my password, this is my password. I can increase the password length, let's call it 16. So this is 16 characters, 16 characters, 16 characters, each of them different. Let's add more symbols here. For example, let's add question mark here, this mark, this, and this one, also some symbols like this. If I do this, we will have chance to get some symbols.